We are checking out part B-2 of the January 2024 Chemistry Regents exam. For some reason you didn't go through part A or part B-1, I'm going to go ahead and put a little notification up here. You might want to start from the beginning. You don't have to. There are actually 4 parts of the Regents exam. This is the 3rd part. The 3rd and 4th part are all short answer type questions. The first 2 parts are multiple choice. Let's go. All right, for 51, we're going to determine the molecular formula for a compound that has an empirical formula of CH2O and a molecular mass of 180 grams per mole. One of the major keys for a chemistry regents exam is the vocabulary. Empirical formula, that's your lowest whole number ratio of the different elements that make up a compound. And then molecular formula is the actual formula for the compound. This is a 3-step type of calculation. It's really simple. The first thing we're going to do is we're going to figure out the molar mass for the empirical formula. Then the molecular formula is some multiple of the empirical formula mass, and we're given the molecular mass as 180. So first thing when we're figuring out a molar mass, I always tell students, list the elements, the number of times they appear in the formula. We're going to multiply by the atomic masses on the periodic table. Carbon is 12, hydrogen is 1, and oxygen is 16. If you don't know that, obviously open up the reference tables and check it out. Then we multiply these out, and I'm running out of room, so I'm going to put it here. It is 12, 2 times 1, 2, and 16. I go ahead and add them up, and I got 8, 10, and I have a molecular mass for the empirical formula of 30. The next step is to take the molar mass of 180 and divide by 30, and I'm going to get a factor. That factor then gets multiplied through the empirical formula. Well, 180 divided by 30, use your calculator, is 6. So that means our molecular formula is C6. H, 2 times 6 is 12, and O, 6. Let's move on to 52 through 54. For these 3 questions, we have information here at the top. Sometimes you need it, and sometimes you don't. It just depends on the questions that are asked. In the case of 52, it says state the trend in atomic radius for these 4 elements as they are considered in order of increasing atomic number. Don't think that these necessarily are an increasing atomic number. You need to go to the periodic table, and you might even want to go to reference table S. Let's take a look. We are looking at group 17. Of course, you should know that these are the halogens. And let's take a look at the order as you move down the group. Fluorine, chlorine, bromine, and iodine. You have more electrons, obviously, and more protons and neutrons too as you go down the group. So the size of the atoms get larger as you go down. If you weren't sure about that, or you wanted to make absolutely sure and double check, you could go to reference table S. And here on reference table S, you have a lot of information. You can see up here at the top. In the question, though, it's asking about atomic radius, and you could go ahead and find the halogens again, the fluorine and the chlorine, and then bromine and iodine, and pull off the numbers. And then, of course, they would continue larger as you go down. I would do all 4, or at least 3 to make sure, but the trend is that the atomic radius is increasing as you go down the group. That is the answer for 52. Let's move on to 53. Determine the mass of a sample of iodine that has a volume of 2.5 centimeters cubed at room temperature and standard pressure. Now you're looking for a mass. And you might think, well, if I have moles, I can have the gram formula mass and I can calculate it that way. Well, one of the things that you have to realize as a student, you have to work with the information that's given. And in this case, you're given a volume. So by being given a volume and you're looking for a mass and you have reference table S, what you're going to do is you're going to need the density of iodine to go ahead and do this calculation. Let's go find it. I already circled it here on reference table S. The density is 4.933. We need that in our calculation. If it's hard for you to go straight across, use the straight edge of the test, literally when you're taking it, as a ruler to make sure you don't read something up or down and you have the correct number. At this point, I just wrote it down so you see it. We have the formula. We're going to plug in the numbers. The 4.933 comes off of reference table S. The 2.5 is from the question, and we're solving for mass. Now, make sure that you know how to quote unquote solve for x here. We want to get x alone. 2.5 is the denominator. That means we need to multiply both sides by 2.5. Sometimes, so students see it, they'll take the 4.933 and put a 1 in the denominator, and then they know they're just cross multiplying. Whatever works for you works for me, but you need also to use your calculator and make sure you get an answer. When I put these numbers in my calculator, I get an answer on the calculator of 12.3325. Didn't ask about significant figures. Don't worry about it. I could just round this to 12, and it's 12 grams. You don't even have to worry about the unit. If you had put 12.3 or 12.33, you would still be marked correct. Typically, if they're going to ask about significant figures, it's going to be a separate question. For 54, state in terms of electrons why these elements have similar chemical properties. Hopefully you remember when you have a group and you look at the different electron configurations of the elements in that group, they all have the same number of valence electrons. And it's those electrons that are involved in bonding. If you're not sure, go to the periodic table. Let me show you over there. We're back at the periodic table, and all I want to point out to you is that each one of our halogens here, the very last number of electrons in the electron configuration is 7. That's what makes them a group or a family that has similar chemical properties. All right, for questions 55 and 56, you're given a balanced equation. You're told you have solid calcium carbonate, and it's going to break down into calcium oxide and carbon dioxide. And let's take a look now at 55. State the molecular polarity of a CO2 molecule. Well, this is one of those where you either have to remember the polarity of some of the molecules or how to figure it out. There's only certain molecules usually that you're asked about. It's just easier to put them into the categories and know which ones are which. They're not asking about bonding polarity, they're asking molecular polarity. For bonding polarity, that would be that carbon is a different element, nonmetal, than oxygen and would be a polar bond. But the arrangement of the atoms in this Lewis structure is a non-polar molecule. That's for 55. That's a favorite of the Regents. I would know that one backwards and forwards. Polar bonds, non-polar molecule. For 56, we're going to reference table S. Determine the electronegativity difference between oxygen and calcium in calcium oxide. Literally all we have to do is find the two numbers and subtract them. Here we are at reference table S. Oxygen's 3.4 and calcium is 1. Just subtract 1 from 3.4 and you get 2.4, which is your answer. Now, very quick thing. When you are working with the periodic table and the other reference tables, especially on the exam, mark up the reference tables. They are yours to use. Literally circle things like I'm doing here in the video. You don't want to make a mistake. Same thing again, I mentioned using your calculator to answer questions. You want to be very deliberate when you practice. You can always grab another set of reference tables from school, hopefully from your teacher, to keep home, mark them up, print out another set so you have them and you're practicing with them. Mark the heck out of them. You don't want to make any silly mistakes. Okay, for questions 57 through 59, we have information here about solid ammonium chloride being dissolved in 100 grams of water, and you're at 25 degrees Celsius, and you're given some information. For 57, classify in terms of saturation the type of solution produced. What they're asking for is the solution unsaturated, meaning you could add more and it would still dissolve. Saturated, meaning you've maxed out the amount of ammonium chloride in that 100 grams of water, and if you add more, it'll just fall to the bottom. Or is it called supersaturated, where if you add more, you have all this excess coming out? Well, in terms of saturation, we have to go back to the little reading passage here, and we're told that we added the 20 grams to the 100 grams of water, and after thorough stirring, no undissolved ammonium chloride remains. In other words, we have a solution that is unsaturated. More can fit. And that's our answer for 57. For 58, we're going to go back to the reference tables. We got to go to reference table I, and we have to figure out the piece of evidence that tells us that this dissolving process is endothermic. Now, endothermic, you should already know this, right? Means that you have this dissolving process that is grabbing energy from the surroundings. And we're going to go ahead. We have to find ammonium chloride and water in reference table I and figure out how we know it's endothermic. Here at reference table I see a bunch of reactions and the heat of reaction associated with it. You see numbers with negative signs and with plus signs. Now, if you don't remember, a negative sign means exothermic and a plus sign means endothermic. Luckily, at the very bottom of the reference table, we're told or reminded that a minus sign indicates exothermic. Well, we were talking about ammonium chloride and ammonium chloride dissolving in water, and lo and behold, we have a positive value for our heat of reaction. And that's our evidence that it is endothermic. For question 59, state in terms of particle distribution. Very important here, anytime a question has the three words in terms of, make sure you answer it with whatever follows in your answer. Since this is a homogeneous mixture, what that means is the ammonium chloride is distributed equally throughout the solution, or that you could say the particle distribution for this homogeneous mixture is that the ammonium chloride is distributed throughout the mixture. Very important. You can make a true statement about a homogeneous mixture, but if you didn't state it in terms of particle distribution, you wouldn't get the credit. For questions 60 and 61, we're given a heating curve. Now, before you even look at the questions, what I always tell my students to do is to label the parts of the heating curve. Now, you're told it's a heating curve to begin with. So the temperature is rising. Hopefully you remember plateaus mean you have phase changes. There's two phase changes here. So we have solid, liquid, and gas. And then at the plateaus, we have solid to liquid and liquid to gas. In 60, identify the interval which the average distance between the particles is the greatest? Well, if you think back to the particle diagrams, which are literally circles representing atoms, and then circles touching one another representing compounds, when you have a substance in the gas phase, they are certainly going to be farthest apart from one another. And the interval would be EF, or E to F. For 61, state what happens to the potential energy of the particles during the melting of the substance. The melting is occurring here at this first plateau, solid to liquid, and the reason there's a plateau, the temperature is remaining constant anytime you have a phase change. When temperature is constant, so is kinetic energy, right? Temperature is a measure of the average kinetic energy of the particles that make up a substance. These go hand in hand, but I'm still adding energy. That energy is going into potential energy. In this case, then, what's happening is the potential energy is increasing. Those atoms or molecules of this solid now, because they're starting to separate, have more potential, right? Let's say to chemically react. All right. So again, potential energy here in 61 is increasing. Here we are at the last 4 questions of part B-2, and we have a 30 milliliter sample of HCl exactly neutralized by 18 mils of 0.1 KOH. During this laboratory activity, appropriate safety equipment was used and safety procedures were followed. All right, we're dealing with HCl, which is an acid. We're dealing with KOH, which is a base. For 62, state the color of brome cresol green indicator if it were added to a sample of 0.1 molar KOH. Well, if I just have a base in solution and no acid, it's definitely going to have a pH value greater than 7. We need to go to the reference tables and look at brome cresol green. Before we get to the indicator reference table, let's just check out a couple of things here. For common acids, we have reference table K. The word acid is in the naming of an acid. If you're not sure if you have an acid or a base, you can certainly go to this table and check it out. With the bases, they are typically a metal and OH. But the exception that I wanted to mention is ammonia, or NH3. That is also base. It has basic properties. Again, just like the other reference table, if you're not sure, you can certainly come and take a look and figure out if you have acids and bases. On to reference table M. All right, here we are. Don't let this reference table intimidate you. Of course, I had to find reference table M again. We're looking at brome cresol green. Here it is. And the way that this table works is you have a color change on one side of the pH values, and then you have another color change on the other side. And in between, whatever range you're given, in the case of brome cresol green, it's 3.8 to 5.4, you have a transition of yellow to blue. The actual indicator would go from yellow to like yellow green, then green yellow, and then green blue. You get the picture. If I'm dealing with brome cresol blue and a base like KOH, and my pH is greater than 7, we're greater than 5.4, which means the color would be blue. For number 63, here is our significant figure. Question, state the number of sig figs used to express the concentration of KOH. I go back to the reading passage. Here it is, 0.10. I have a number less than 1. This first 0 is a placeholder. It does not count. Just count the numbers, including 0, to the right of the decimal, and my answer here is 2 sig figs. For 64, determine the concentration of HCl sample using the titration data. Let's go to reference table T, we'll get the equation, and then we'll come back and plug in. I'm here at reference table T. I'm going to go ahead and maybe try to scroll down. And here is the titration equation. Molarity of an acid times the volume of the acid is going to be equal to the molarity of the base times the volume of the base. Let's go back. Notice I wrote down the equation. I think it's very important that you do, or you have a piece of scrap paper, or you do it on the test here as you're going through it. And I also recommend for students you put the acid, in this case is HCl, on the acid side and the base KOH on the base side. If we go back to our reading passage, 30 milliliter sample of HCl. Well, 30 mils, and you don't have to put the units, but that's on the acid side, was exactly neutralized by 18 milliliters. All right, so we have our 18 milliliters of 0.10 molar KOH, 0.10, and we're looking to figure out the concentration of the HCl, which is the molarity of the acid. All right, at this point, you have your setup, and we're asked to determine the concentration, which means we have to do the calculation. You're grabbing your calculator. You got 0.1 times 18, which yes is 1.8. I would plug it in anyway. And then we need to get the molarity of the acid alone, which means we're dividing by 30. And we get an answer of 0.06. 0.06. That ends part B-2. I'm so glad if you made it to the end. Good for you. You keep going. I'll be posting part C very quickly. Please go ahead and join my YouTube channel if you haven't already. And again, when a couple other things are posted before the exam, you'll get a notification. No matter what, keep on working hard and good luck.